Okay, so in this problem, we are drinking root beer from a conical cup. The cup has a diameter of 8 centimeters and a depth of 10.
Hot cones.
The root beer is leaving the cup at a rate of 7 centimeters cubed per second. So we know that that is going to be our dV dt, but since it's leaving the cup, we're going to make it negative. So we have negative 7 centimeters cubed per second. At what rate is the level of the liquid in the cup changing when the liquid is 6 centimeters deep? So we're solving for dH dt. And that is when h is 6 centimeters. So we're going to use the volume equation for a cone to relate all of our variables. So we have V equals pi over 3 r squared h. And again, we don't want to have two variables in this equation. Since we're going to solve for dH dt, we want to replace r. So if we look at our cone, we know that r over h equals 4, since the diameter is 8, 4 over 10, or 2/5. So we know that r equals 2h over 5. And that's what we can plug into our volume equation. So our volume equation is going to be pi over 3 r squared, 2h over 5 squared, because we are replacing the r, h. And if we simplify that, we'll get 4 pi over 3 times 25, so 75, h cubed. So now we're ready to take the derivative of our equation. So dV dt will equal, if I multiply by 3, I can cancel the 3 with the 75. So 4 pi over 25, h squared, dH dt. We want to isolate dH dt, so we'll divide by 4 pi over 25, h squared. And we end up, we know that dV dt is negative 7. So we end up with negative 7 over h squared. And to simplify it, we can multiply that by the reciprocal, which would be 25 over 4 pi. And that gives us dH dt. So we have negative 175 over 4 pi h squared. So now we want to know what the rate is of our height when h equals 6. So we'll plug in 6 for h. So we get negative 175 all over 4 times 36, which is 144 pi. And let's see, can we reduce that? We'll just leave it as negative 175 over 144 pi, centimeters per second. And that is dH dt. in this problem, we have a 20-foot ladder that's leaning against a vertical building. My building is purple. If the top of the ladder is sliding down the building at a rate of 3 feet per second, how fast is the bottom of the ladder moving away from the building when the top of the ladder is 5 feet from the ground, 1 foot from the ground? So in this case, we have the rate of the ladder that is sliding down the building. So we need to make our rate negative. So since I labeled my building Y, I'm going to name the rate that it's sliding down dy dt, and we'll call that -3 feet per second. Since we want to find out how fast the bottom of the ladder is moving away from the building, I labeled that x. So we're going to be finding dx dt when x equals 5. Oh no, that's not what we're finding. When y equals 5. So let's change that x that I wrote down to a y. So when y equals 5, and then later when y equals 1. So we need to write an equation that would relate all the variables, and since we're working with a right triangle, we can use Pythagorean theorem. So I'm going to have x squared plus y squared equals 20 squared. And take the derivative of that, which would give me 2x dx dt plus 2y dy dt equals 0, since 20 squared is just a constant. And since we want to solve for dx dt, I'm going to isolate that variable. So 2x dx dt equals -2y dy dt, and we'll divide by 2x. So dx dt equals -y over x dy dt. And since we know that dy dt equals -3, we know that dx dt equals positive 3y over x. So now I want to find dx dt when y equals 5. So when y equals 5, I still need to figure out what x would equal based on my right triangle. So let's redraw our triangle. And when y is 5, I want to find x, and the ladder is still 20. So if we do Pythagorean theorem, equals 5 root 15. So that's what I'm going to plug in for x. I always forget units. Feet per second. Feet per second. If we want to find dx dt for when y equals 1, we will do the same thing. So I want to recreate my triangle. My ladder is 20. My height is 1. So we want to solve for x. So x equals the square root of 399. So dx dt equals 3 times 1 over the square root of 399. And since these numbers are kind of funky, we'll use a calculator to figure that out. So we get 0.150 feet per second.